My name is Jose Carlos Macedo, and today I will talk about one of the senses of fish, touch. Touch is assumed to be the primary connection of a living being with its environment. Fish use the information obtained by their tactile organs for orientation, feeding, defense, reproduction, or other vital manifestation. It is thought that this sense is so ancient that it was present in early prokaryotes. It is through touch that animals recognize external stimuli and take the appropriate action. Tactile sense is an orchestra of reactions performed every time the skin, subcutaneous tissues, and superficial mucosa encounter a mechanical difference in the environment. This can either be pain, which is called nociception, temperature, which is called thermoception, or position, which determines movement in space. Fish use specialized cells or receptors that are situated in the skin and mucous epithelial envelopes. These cells are nerve endings coming from the spinal cord. These may be encapsulated on myelin or Schwann cells depending on the type of variable it identifies. These receptors are categorized depending on the speed at which they are stimulated. This can be the Pacini corpuscles, which are conformed by cells that surround a nerve ending, perceive brief mechanical stimuli sufficient for the formation of skin by 1 micrometer only, detect vibrations from 200 to 400 Hz. The other ones are Meissner corpuscles, consist of spirally coiled nerve endings surrounded inside a collagen capsule. It participates in the identification of form and texture of things, detects 10 to 200 Hz. We also have the Clausen organs, composed by a laminated capsule surrounding a rod-like or spiral nerve ending. They react to relatively low frequency vibration within the range of 10 to 100 Hz. On the other side, we have the slow reacting receptors, like Merkel cells. They are widely distributed through the skin and possess microvilli to connect it to surrounding cells. They detect local pressing and high spatial discrimination of stimuli. The Ruffini ending is a capsule of connective tissue that surrounds a ramified network of thin branches of a nerve ending. They perceive local actions on skin, like displacement, touches, etc. These cells unite with other tissues in order to form tact organs. For example, we have free rays. These organs help the abyssal animals locate their prey using the passing of water currents over their rays, which are covered by mechanoreceptors. Other ones can be barbels. These are epidermal outgrowths, tentacular in form, that in fish are situated on the head, frequently near or around the mouth. They'll help locate prey in low light conditions. Reproductive tubercles, commonly known as breathing dress, these are structures formed at the beginning of the reproduction period, almost from the same materials as nails. In most species, in males only. If they are present in both sexes, they are less developed and smaller in females. The rostrum helps bottom feeders such as the elephant nose, who has an elongated roboscidean rostrum. It is thought that food search in this fish is made with the participation of numerous receptors. Fish use these organs to interact with their environment or with other fishes. Some behaviors they show are protection, orientation, reproduction, or feeding. When on early stages of life, some will not have developed enough sight, so they will use their heads to hide under rocks. Other example is feeding in catfish, where they use their variables to taste their environment. The closer they get, the tastier it gets. Usually they will follow other peers looking for the same. Hammerheads use their lateral line to determine when they are up or down. This helps them hunting skate rays. On the reproduction example, we have seahorse, Hippocampus gutulatus. The spawning behavior comprises a breeding dance or so-called carousel swimming when a pair of seahorses turn around and being pressed to each other ascend above the bottom. Having reached the top of the ascent, the female introduces the end of the genital papilla into an opening of the incubator pouch of the male and lays eggs. Even though fish will have tact all along their life, the way they perceive it changes as they grow. The development of mechanical sensitivity starts from the early stages of the embryo, but as the fish grows, it changes its morphology as well as how it perceives the world. For example, in flying fish, the early stages have elongated barbels to help them find food in the dark bottom dwellers. For example, flying fish will have elongated barbels to help them sense their way in the dark depths of the ocean, and a fin for swimming low. As they grow to a juvenile stage, the barbels and fin will get smaller and the fish is beginning to swim in the upper zones of the ocean. Finally, are ready to fly, fish has the adult form with no barbels. This makes it more aerodynamical. After all we've seen on this video, I have to tell you that the tactile system of fish is still little known. Until now, information on morphology of tactile receptors of fish is scarce, even though what's available clearly demonstrates that most forms of behavior and principal vital functions of fish, like feeding, reproduction, and defense, occur with the participation of tactile reception. In many cases, tactile sense is crucial for the sole method of obtaining the necessary information, and some behavioral reactions obviously cannot be realized without its participation. Thank you very much. Hello, my name is Jose Carlos Macedo, and today I will talk about one of the senses of fish, touch. Touch is assumed to be the primary connection of a living being with its environment. Fish use the information obtained by their tactile organs for orientation, feeding, defense, reproduction, or other vital manifestation. It is thought that this sense is so ancient that it was present in early prokaryotes. It is through touch that animals recognize external stimuli and take the appropriate